If you are going to watch this video till the end, I assure you that you will be mastering Mann-Whitney U Test, hypothesis testing. In this video, we are going to cover what is a non-parametric test, when to use Mann-Whitney U Test. We will see how we can formulate the hypothesis for it, and we'll see it with an example, and then a hands-on implementation using Python. Hello everyone, my name is Animesh and welcome to my YouTube channel. If you have not subscribed to my channel yet, please do subscribe to my channel so that you do not miss on anything, because I always try to upload the rich content which is authentic. So let's begin. So what is a non-parametric test? So we perform non-parametric test on the data that is ordinal, or it can be interval or a ratio data, but it is not a normally distributed data. You see how a normally distributed data looks like. In A figure, you see normal distribution. This symmetrical dumbbell shaped curve is equally divided by the mean line on the either side. That is why it is called normal distribution. And if I look at the B figure, you see the data is left skewed, that is negatively skewed, and on C that is positively skewed, that is right skewed. So this type of data where the mean, median, mode are not falling in the same line is a non-normal distribution or a non-parametric data. So on these type of data, that is B and C, we are going to use the non-parametric test. Okay, so let's continue. So in such scenario where the data is not normally distributed, we use Mann-Whitney U test to know the distributions are same or they differ. So this test is also known as Wilcoxon rank sum test. It is a non-parametric test, as we all know now. It is used to compare two independent samples to determine whether their population distribution differ. It is an alternative to two-sample t-test. Now the question arises, what if the data is normally distributed? For that we use the t-test. So in order to know how the t-test is performed, I have already made a separate video on that. You can check that out. I will share the link in the description. Then another question is that how do we test whether the data is normally distributed or not? So there are hypothesis testing for that. I will share the link of that video as well that I have already created for you guys. Now when to use this test? So this test is used when we need to compare two independent groups. The first assumption is that the two groups are independent of each other. Then second, that we already discussed, that the data is not normally distributed. Let us take some example. An example can be comparing test scores between two groups of students, group A and group B. In these kind of scenarios, we apply Mann-Whitney U test. Now, how would we draw the hypothesis for this? So, although there are three scenarios, but let us take one scenario, case 1. So null hypothesis, we will form that the two groups have the same distribution, and the alternate hypothesis will be the two groups have different distribution. Now when we run the test and we take out the p-values and the statistics, if the p-value is less than 0.05, we can be 95% sure that we can reject the null hypothesis. That is, the two groups have different distributions. And if the p-value is greater than 0.05, we fail to reject null hypothesis. That means the two groups have the same distribution. Now let us do the hands-on in Python how we can perform this test. I have opened the Jupyter notebook and you see that I have already laid out the null and the alternative hypothesis. Before we begin to code, if you have not installed the scipy library, you might need to install it. If you are installing it via Jupyter Notebook, you need to install it with an exclamation mark, and if you are doing it via command line prompt, you can do it directly pip install scipy. Now there are three types of scenarios: two-sided test, less test, greater test. Now two-sided test is basically having the null and alternate hypothesis in this fashion. that it is testing only whether distribution are same or different. Hence, our null hypothesis will be the two groups have the same distribution. Alternate hypothesis will be that the two groups have different distributions. That is, the distribution of group A is not equal to distribution of group B. Now let us look at how we will code to perform this test. So first we will import the scipy.stats and we will import the Mann-Whitney U test, and we have the data of group A and group B scores, which we will pass in Mann-Whitney function, and we will pass group A first and then we will pass group B, and we will give alternative equal to two-sided. So we will come to it why we are passing this parameter. By default it is two-sided, but there are other parameters that is greater or less. We will discuss why that. And we will also write stats comma p-value because the output is going to be a tuple and we need these two values. And I have created a if and else block for it. So if p-value is less than 0.05, we have a statement reflecting what will happen to our null hypothesis, whether we are going to accept it or reject it, that we earlier discussed. So it will return us the correct answer. Now let us execute it. This may take some time. Okay, so we have the p-values, and p-values is minuscule. It is much lower than 0.05. Hence, with this we can conclude that the p-value is small, so we reject the null hypothesis, and we conclude that the distribution of A group and B group is significantly different. Now, in the context of the Mann-Whitney U test, the terms distribution less or distribution greater refers to the directional alternative hypothesis. These alternatives specify whether one group's data tends to be smaller or larger than the other group's data. So here is the breakdown. So here we see less. So this test if the distribution of the first group is less than the second. So our null hypothesis would be the two groups have the same distribution, but our alternative hypothesis would be the first group tend to be smaller than those in the second group. And in the alternative parameter we will pass less instead of two-sided. By default it is two-sided, that we already discussed, but if you want to do with less, then we will pass less. If you want to go for greater, we will pass greater. So let's talk about greater also. The alternative hypothesis will change. The first group tend to be larger than those in the second group. That is, distribution of group A is greater than distribution of group B. Now let us perform the test for the less as the direction, and I will just bring the same data of group A and group B, and we'll perform the Mann-Whitney U test, and I'll pass the parameters group A data, group B data, and in alternatives I will pass less. Okay, only this is the difference, and I will change my statements that the first is the p-value is small, so we reject the null hypothesis and conclude that group A scores are significantly smaller than the group B score. Okay, and alternate hypothesis would be we conclude that group A scores are significantly larger than group B score. Okay, so let's execute this, and I get p-value as very small, which is 0.003, which is much smaller than 0.05. Hence we will conclude that the p-value is small, so we reject the null hypothesis and conclude that the group A scores are significantly smaller than group B score. Okay, similarly, let's carry out the hypothesis testing for greater as well. So we'll take the same data and we'll use the same function in the same manner, but in the alternative parameter we will just change from less to greater now, and then we will change our result that p-value is small, so we reject the null hypothesis. We conclude that group A scores are significantly larger than group B score. Okay, and our alternative hypothesis will be, we conclude that the B score are significantly larger than group A scores. In earlier, it was group A score larger than B, and here in alternative it is group B score significantly larger than group A score. Okay, now let us execute this, and we get p-value is 1, which is higher, much higher than 0.05. Hence, we fail to reject the null hypothesis, and we conclude that group B score are significantly larger than group A score. So we covered what is a non-parametric test, what is a non-parametric data. We also covered what is Mann-Whitney U test and when to apply it. We also saw how to create the hypothesis, and we did the implementation of hypothesis testing using Python scipy library. So that is all in this video. I hope you guys like this video. Please do subscribe to my channel, and I'll see you in the next video. Till then, take care.